Hello, everyone, and welcome to today's session. We are going to spend the next few minutes exploring two ideas, the foundation of everything you will do as game technologist game gamification and game design. By the time we are done, you should be able to walk into a design meeting and explain not just what makes a game fun, but why it is fun, using the same vocabulary professional designers use mechanics, dynamics, and aesthetics. Let's get started. Definition of gamification. Let's start with a clear definition. Gamification is the application of game design elements in non game context to enhance user engagement, motivation, and participation. Non game context. That's the key phrase. We are not talking about building a game, we are talking about taking pieces of what makes game compelling points, levels, feedback loops, competition, and bolting them onto something that isn't inherently a game. For example, a fitness app, a language learning platform, a corporate training module, even our college LMS dashboard with progress bars. So remember the distinction. A game is built to be played for its own sake. Gamification borrows game elements and injects them into something else, usually to change the behavior. The gamification revolution. Now, where is this actually being used? Gamification has spread across almost every domain you can think of: health apps, marketing, workplace, productivity tools, and very heavily education. Let's focus on education for a moment because it's the clearest example. Traditionally, learning is passive, listening a lecture, referring a textbook, attending a test. Gamification flips that. By introducing game mechanics, game dynamics, and game design techniques into a classroom or a e-learning platform, you can transform a passive experience into an active one. Students aren't just receiving information anymore. They're participating in a structured system that rewards effort and progress. Think of Duolingo, streaks, XP points, leaderboards against your friends. None of that is learning Spanish in the traditional sense, but it makes you want to open the app every day. That's the entire philosophy in one example. The goal fundamentally is to make learning or any non game task feeling as captivating as playing an actual game. What is gamification? A bit of history now. The term gamification was actually coined back in 2002 by Nick Pelling, a computer programmer and writer. So, this is not some buzzword from the last 5 years. The concept has been around for over 2 decades. What changed is the scale. Mobile phones, apps, and constant connectivity gave gamification the infrastructure to explode. In an educational context specifically, gamification means using game elements to boost learning outcomes and student engagement. And the toolkit is fairly standard. You'll see it again and again: points, badges, leaderboards, and challenges. Each of these does a specific psychological job. Points give instant feedback. Badges give a sense of achievement and status. Leaderboards introduce healthy competition. Challenges give structure and a clear goal to chase. Put together, the aim for educators is simple: make students more engaged and build a more positive attitude towards the subject they are learning. As future developers, this matters because you will likely be the one implementing these systems. So, understanding the intent behind them helps you design them well. not just code them. Neuroscience of gamification. Now, here's what is gets interesting from an engineering and design standpoint, because gamification is not just a UX trick. It's grounded in actual brain chemistry. Research shows that gamification triggers the release of dopamine. Dopamine is a neurotransmitter associated with motivation, pleasure, and reward. When dopamine is released, feel a genuine spike in motivation and enjoyment. That's not a metaphor, that's measurable neurochemistry. Now, where does this happen? The hippocampus. This is the part of your brain responsible for memory, specifically how much information you recall and retain. Interestingly, dopamine is also released from the hippocampus itself, and this helps you to maintain focus on the task in front of you. So, here is the chain. A well designed game mechanic, say completing a level or earning a badge, triggers dopamine release, which is tied to the hippocampus, which is your memory center. The result, gamification doesn't just make a task feel more fun in the moment, it actually stimulates the hippocampal memory system, helping convert new information, pushing it into the long term memory. This is precisely why a well gamified lesson can be more memorable than a standard passive lecture. It's not just engagement, it's biology working in your favor. Gaming industry. Let's zoom out and look at the bigger picture. The industry you are about to enter. The numbers here are honestly staggering. According to a PwC report, the gaming industry is on track to be worth around $321 billion by 2026. Look at the chart. Consistent, almost relentless year over year growth. A big reflection point was COVID 19. During lockdowns, millions of new players picked up consoles and games for the very first time. People who pre pandemic may never have considered themselves gamers. And interestingly, this wasn't purely about entertainment. A lot of players reported that gaming actually helped their mental health during an extremely isolating period. It gave people a sense of connection, routine, and escape. Now let's flip to the other side of the coin, game design, the actual discipline of designing games. Introduction to MDA. Game design, at its core, is an intricate process that blends art and science. It's not purely creative intuition and it's not purely technical engineering. It's both woven together. The framework we are going to use to unpack this is called MDA, Mechanics, Dynamics, and Aesthetics. You'll see this Venn diagram a lot if you go further into game design theory. It was formalized by Robin McLeBlanc and Robert Zubeck, and it's become close to an industry standard for talking about games in a structured way. Here's the simplest way to think about it. Mechanics are what you build. Dynamics are what emerges when players interact with what you build. And aesthetics are what the player actually feels. As a designer or engineer, you have direct control over mechanics. You have indirect influence over dynamics and aesthetics. The emotional experience is really the end goal. Everything else is serving. Understanding mechanics. First, mechanics are rules, systems, and interactions that govern how a game actually functions. This is the literal codable layer. If you are an engineer, this is the part you implement directly. Whether it's jumping over an obstacle, solving a puzzle, or engaging a combat, mechanics dictate exactly what actions a player is allowed to take, what consequences follow from those actions. If I press the jump button, what happens? If I collide with an enemy, what happens? That entire rule set, the if this, then that logic of your game is mechanics. This is the layer closest to your code. Collision detection, input handling, state machines, all of that exist in service of defining the mechanics. Understanding mechanics with examples. Let's ground this in real examples because abstract definitions only get you so far. Take Tetris. The mechanic is simple: rotate and place the falling blocks to complete lines. That's it. One core mechanic endlessly repeated. Now take Minecraft, a much more complex system. Core mechanics here include mining, crafting, and building. Multiple interlocking mechanics, but each one is still just define a rule set for player action. And Among Us, the mechanics revolve around completing tasks, or if you're the imposter, eliminating other players while avoiding detection. Notice something important across all three. Mechanics define the possible actions a player can take, and they set absolute foundation for everything else in the game. Nothing else. No dynamics, no aesthetics can exist without this layer being defined first. As engineers, this is usually where you will spend the bulk of your implementation time. Dynamics. Now we move one level up: dynamics. And the definition here is short but important. Dynamics describe how the game state changes over time as players interact with the mechanics you have built. Notice the shift in language. Mechanics is about rules, dynamics is about behavior, which actually happens when real players with their own strategies and personalities start using those rules. This is the layer you can't fully control through code alone, but it emerges from player choice. Examples for dynamics. Let's go back to Among Us. The dynamics, as we said, are tasks, discussions, and voting. Those are the coded rules. But the dynamics are the social strategies that emerge on top of those rules: accusations, alliances, deception. Nobody programmed betrayal directly into Among Us. It emerges naturally from simple mechanics combined with human social behavior. That's the magic of dynamics. Same story in Fortnite. The mechanics are shooting and building, but the dynamics, ambushing, teaming up, outbuilding an opponent in a base building standoff. Those are emergent behaviors. They weren't hard coded, but arose from players interacting with the mechanics in creative ways. So, dynamics capture how the game evolves in real time and, crucially, how players end up shaping their own experience within the boundaries the designer set. This is why great game design is not about controlling every outcome. It's about designing mechanics flexible enough to produce a rich, unpredictable dynamics. Exploring aesthetics. Finally, aesthetics. And I want to be clear, this doesn't just mean graphics. In the MDA framework, aesthetics refers to the full sensory and emotional experience evoked by a game: visual design, audio design, narratives, atmosphere, all of it combined. This is genuinely the most important layer because it's the output the player actually experiences. They don't experience your collision detection code. They don't consciously analyze emergent social dynamics. What they walk away remembering is a feeling. And that's why understanding the interplay between all three layers mechanics, dynamics, and aesthetics is what separates a good game designer from someone who just writes functional code. You're not just building systems, you're engineering an emotional outcome. Exploring aesthetics with example. Let's close with examples that show how differently aesthetics can land, even though they are all built from mechanics and dynamics underneath. Journey creates a feeling of awe and serenity almost entirely through its visual design and musical score. There's barely any dialogue there's barely any dialogue in the entire game. Dark Souls, on the other end of the spectrum, evokes tension, fear, and ultimately triumph through a deliberately dark atmosphere combined with punishing difficulty. The feeling of finally beating a boss after 20 attempts is the aesthetic payoff of that design. Candy Crush, a far simpler on the surface, delivers delight and satisfaction through bright colors, rewarding sound design every time you make a match. Three completely different emotional targets, three completely different aesthetic toolkits, but all of them are the reason mechanics and dynamics exist in the first place. Aesthetic are what make players feel emotionally invested in a game. So, to bring it all together, today we covered gamification, how game elements migrate into non game context, backed by real neuroscience and a booming industry. Thank you.